Hi folks, today we're going to talk about how to standardize titrant using KHP to get the most accurate titrations possible. Let's have a look. So the first thing I'm going to do here is I'm going to take my KHP, this is potassium hydrogen phthalate, and I'm going to put it into a secondary container so I don't contaminate the whole bottle. Don't need a lot, we're going to need 50 milligrams for each of the three reactions we do. And I'm going to weigh this out. It doesn't have to be exactly 50 milligrams, 0.05 grams, but we should be close. So I'm just going to go ahead and weigh out three portions and record those masses. $53 milligrams, 0.053 grams. That's going to go into my first. I have a stir bar in this. $55 milligrams. Go into the second one. Again, it doesn't have to be right on. We just need to know how many moles we want. We don't need a lot of this. So, re-tare this guy. Looks like he's right on. And finally, I'll get my last one. Do a little better than that. That's why you want to use a secondary container so you don't waste too much of the original. And go back into the stock bottle. Of course. Oh well, we can deal with that. 0.062 grams, 62 milligrams. And then I'm going to get these guys dissolved in the minimum amount of water possible. So I want to get these dissolved. I'm going to try to get them dissolved in the minimum amount of water that I can. Doesn't have to be a whole lot. I might move this over to the stir plate just to help it get going. Stir bar going. Maybe add a little bit more water. It's not really critical how much water you have in there as long as it's all dissolved. Looks like it's going to be about 10 mils total for this one. And then I'm going to add 5 or 6 drops of phenolphthalein, the indicator. 1, 2, 3, 4, 5, 6. Extra one to grow on. And it looks like we're pretty much fully dissolved in there. I'm going to do this for the other two, and then I'll be back. Alright, so now the next thing we're going to do is condition and fill our buret. I have some about 0.1 molar NaOH that I've diluted from a 1 molar stock, and I made 200 mils of this, so we have plenty. The last thing you want to do is to only make a small amount, standardize it, and then run out, and then you have to re-standardize. So I have enough here to last me multiple titrations, and I'm just going to standardize once and know what the concentration is. Give it a good swirl. Remember to standardize your buret. You should first we need to kind of clean it out and condition it with the right titrant. So we're gonna put a little slug of our NaOH into it. You want to make sure that this is closed, and then I like to sit and kind of spin it through the buret. Don't let it come out the end, just to make sure it coats all the surfaces. Make sure that it doesn't have any other thing in there, that this is all coated with our titrant. And then let that run. And you want to make sure there's no bubbles in the tip here. You want to make sure that there's nothing stuck, that all we have is our titrant in the end. This is some dirty titrant, so it was just used to clean it. So I'm going to run it out as far as I can, just into the waste beaker, without getting any bubbles in. And then I'm going to refill it somewhere up into the range up here. I only need probably about 2 or 3 mils per titration, so I don't need to put a whole lot in. Remember, we were trying to preserve this so that we can use it in experiments. Now, if you look up here, my funnel's full, and it's not filling. This happens, you just need to break your suction. This is why you should definitely wear gloves for this. Sometimes you'll get a bubble suction, and it'll run down the outside of the buret. And gloves, when you're dealing with NaOH, is always important. Let's give that a quick wipe down. Funnels are notorious for suction, and especially if they fit just inside like this one does. So, be careful. Don't burn yourself on chemicals. Next step is going to start doing titrations. First thing I might want to do here is record my starting volume. I am at, looks like 13.60, maybe 13.6, yep, 13.61, I'm going to estimate. That's my starting point, and that's where I'm going to write down in my notebook my starting point. Okay, so I have my first solution of KHP on the balance. That was my 53 milligram portion, and I'm going to start adding titrant slowly to the mixture. You don't have to go very fast, just go a little bit at a time. You can see that the pink is going away really rapidly. I always have a squirt bottle of distilled water in. I can wash individual drips straight in. It doesn't matter what volume you're using. And that's a nice way to get small volumes to go into the solution without having to worry about it. So keep going. Pink is starting to stay a little bit longer before it goes away. I'm going to start watching for it to stick around slightly longer and longer. When it starts to stick around a long time, I'm going to start washing my drops in with my squirt bottle like I did a second ago. It's starting to stick around quite a while. So I'm going to slow this thing down. Alright, we're getting close. I'm going to wash the drip in and see what we get. Not quite there. A few more. Alright, that's really getting close. And we're getting pretty dang close here, so I'm going to do another drip. Not quite. This has got to be it. That's it. The pale pink. So I can read that last drip that I washed in This is actually maybe a little bit past the endpoint, but it's pretty close to where I want to be. So I'm going to read my volume again. I'm at 16.10. So 16.10. So it looks like I added approximately 2.5 milliliters or so. I think 2.49 of titrant. Now I'm going to go ahead and do the other two, and then I'm going to be able to do the math and solve what my concentration is. All right, so let's just go. I'm going to watch my volume because I know it's about 2.5. So I should expect something around 18.6 or so. And just keep your eye on it. This is a little bit more mass in this one than the last. So you'll get better at this as you go. But still slow down towards the end here. About 18.5 here, so I'm going to go ahead and slow down. Alright, I think this is my last one, so let's wash that drip in. That one, maybe one more. Ooh, tricky. A little bit closer. There we are. Nope, not quite. That didn't stick. There we go. So my volume is 18.70. So that one went from 16.10 to 18.70. Because there's a little bit more mass in that one, I had to do 2.6 milliliters. And then on to number 3. Last one. And again, I'm looking around 2.5 or so, so maybe around 21 mils. Where I should expect the endpoint. This one's going to be a little bit higher than that, of course, because this one is my 62 milligram sample. So this one actually might be a little closer to 22 mils than 21. Okay, we're sneaking up on 21. We just passed it, so we're not even getting close yet. Let's give it a few more. Maybe 1 or 2 more. I'm going to wash the strip and see what we get. Pretty close. So what I'm doing right here is just letting that drip hang and then stopping it, and then I'm going to wash it in. Nope, not quite. Keep doing that until we get it. Whew, close. There we go. Perfect. So there we go. That one's probably the best looking endpoint that I got because it's very pale. In fact, if I let this stir much longer, it's going to head back down south because CO2 is in it. That's probably my best endpoint. Look at my 3 endpoints. You got about the same in the first 2 and then a real pale one on the third. That one may be a little bit below the endpoint, but not very far. So that's what they look like. And my volume is, looks like 21.5 21.51. Write that on down. And we'll do some math. Alright, so here we are back doing our math. So my 3 trials, I had 0.053 grams in the first one of KHP, 0.055 grams of KHP in the second, and 0.062 grams. And my volume of NaOH went from 13.61 grams in the first to 16.10 mils. So that's a change in volume of NaOH equal to 2.49 milliliters. Okay. For the other one, so that's the amount we delivered. For this one, we had 2.60 milliliters. Remember, we want to reflect the precision of our measurement, so we go out to the second decimal place. And then in the third one, we had 2.81 milliliters. And that correlates well with the increasing mass of KHP that we had in the 3 trials. And so now what we want to do is we want to find the molarity of NaOH. And that is the moles of NaOH over the liters of NaOH. So a couple things we need to do is we need to convert our volumes to liters, and we need to find moles. So we can find the moles from the KHP. We can find the liters from our volume from our titration. So I'm going to convert these to liters. That's going to be divided by 1,000. So we're going to end up with 0.00249 liters, 0.00260 liters, and 0.00281 liters. Now, over for KHP, that's going to tell us our moles, because our reaction here, NaOH plus KHP, goes to water, and KNAP, this is phthalate, remember. So we were able to get this H and this OH together to form H2O. So it's 1 mole to 1 mole here. So the amount of KHP equals the amount of NaOH. So equals moles of KHP. That's why we use KHP to standardize. It's a 1-to-1. So we need to convert these. Our molar mass is off the bottle, 204.22 grams per mole. And I'm going to box that because it's going to be used for all of these. So I'm going to convert to moles. So how am I going to do that? I'm going to take our grams of KHP, and I'm going to divide by 204.22 grams per 1 mole of KHP. So for 1, we're going to get 2.596 times 10 to the negative 4th mole of KHP. Okay. Again, this reflects the precision of our measurement out to the 3rd decimal place. 2.693 times 10 to the negative 4th moles of KHP. And finally, our big boy, 0.062 grams, was 3.036 times 10 to the negative 4th moles of KHP. And now it's just a simple matter of taking the moles of KHP, which equal our moles of NaOH, dividing it by the liters of NaOH we used. So for number 1, we're going to take 2.596 times 10 to the negative 4th moles of NaOH, because it equals KHP, divided by 0.00249 liters of NaOH. That's the same thing as molar, and that's going to give us 0.1043. Great. So again, we want to make sure that we're precise to the right decimal place. Over here, our precision is lower than our scale gave us. So that was going to become a second decimal place. That'll be 0.10. And so that should cut off right around right here, right there, 0.10. We'll keep that there though. That looks so ugly, I just can't stand it. Can't move on until this is done. There we go, that looks good. All right, our second one, we're going to do the same process, just using the moles here. So 2.693 times 10 to the negative fourth over 0.00260 liters is equal to 0.1036 molar, and then 3.036 times 10 to the negative fourth over 0.00281 liters equals 0.1080. Okay, so the average here between these three is going to be 0.1053 molar. Okay. If you use a standard deviation, this will be plus or minus 0.0023 molar. So that is our concentration of our titrant. We made it up as a 0.1 molar solution. That's really quite good. We were off by about 5.3% or so, maybe less than 1%. But hey, that is going to make a difference when we actually do our titrations in the lab. So go ahead and do that yourself, and best of luck. Bye.